Computer audio. We are recording. Okay. Hello, is anybody there? Give me a thumbs up if you can hear me. You know, just like that, or you can even make it like that. Hello. We'll wait a minute to get started before see if anyone else comes. I'm going to talk a little bit about chapter 13, which I should get out of the bookshelf here. And I'm going to talk a little bit about the exam. So, okay. So let's see how things go. That's 1 o'clock. If people show up late, they show up late. Okay, let me share a screen, and I want to talk about exams and essay questions and stuff like that. So I have to share a screen. Let's see. Do you see a document of text? It's a Word document.
Yeah.
Yeah? Okay. So this is one of the essay questions, and these are sample answers. They're not anybody's exact answer. So the directions for the essay questions say, write in your own words, 1 paragraph, standard spelling, grammar, and construction. Use examples and details to support your answer. And so the question is, why is water important to the human body? Could you replace water with another chemical? Okay, so it's a 2-part question. And so rather than go over one answer that I do, I've kind of put together two answers, one that's kind of weak and one that's better. And so for first one, the weak answer, it says, without water, your body will not live for more than a few days. Your body is made up 90% of water. Water flushes out toxins, helps you sweat, keeps your skin moist, and improves circulation. No, you cannot replace water with another chemical. You need it to survive. Okay, so that's an answer that's got some stuff in it. You do need water. You can only live for a few days without water, but there are some problems with it. One is that it's mostly just general statements, and it doesn't kind of show that you've done anything with the textbook. And so there's, your body is not 90% water, it's about 60% water. Your body fluids are about 90% water. Water is involved in the kidneys and excretions, but water doesn't flush out toxins. That's a common kind of expression that's not technically correct. Sweat contains water, but really what the book was trying to get at is water carries heat, and it's involved in temperature regulation. Evaporation is an effective way to lose heat. And so that's kind of it's a detail that's not so great. Water keeps your skin moist, improves circulation. It's involved in transport of things dissolved in it. And then, no, you cannot replace water with another chemical. You need to survive. Again, those are general statements that are correct, but don't really help with the question, answering the question. And so, and then there's lots of errors here in spelling, in punctuation, in capitalization, and just in sense. So there's without is misspelled. There's two ofs there. The last statements is really two sentences without any punctuation and with wrong capitalization. And so it's not completely wrong, but it doesn't have any specific details. It has some misstatements of fact, and it's got no explanation, and then it's got these errors in construction. So there were really good answers to this question, and they varied quite a lot. But what they all have in common is that they contain specific details that are important out of the book. They have explanations that are parallel to the book. And then I think that they were proofread, that someone read them over and corrected them. So the better answer is water is extremely important to our body. It makes up 60% of our body. First off, body fluids like blood, CSF, which is cerebrospinal fluid, sweat, digestive fluids, and intracellular fluids are mostly water. Water cushions and supports our joints. Water helps eliminate waste through urinating. Water is crucial to regulating body temperature. Many substances dissolve in water and are transported in water. Water participates in chemical reactions. What makes water so useful is the elements it's made up of, hydrogen and oxygen. They form polar bonds, and thus water forms hydrogen bonds with DNA, protein, and ionic bonds. I don't think you could replace water with another chemical. So it has some specific details about water and water in the body. It parallels a lot of the wording in the book. It's not taken exactly from it. These aren't long, complicated sentences. They're nice and short and crisp, and so they're easy to read, easy to write. And scientists like that. We don't like complicated sentences. We didn't do all that well in English. And so we don't care. We just want it punctuated, capitalized, and that kind of stuff. So these are answers to the same question. Very similar answers in the general idea, but in science, what we want are specific details and explanation, and examples. And so examples of like what a part of the body contains water. Why is water crucial? It's not enough to say you need water, but why is it crucial? And why did the book say it was crucial? And what kind of things, how did they explain water's use in the body? And so you want to be parallel to that. It doesn't have to be limited to the book, but if it comes somewhere else, then you have to be sure the details are correct. And so the flushing out toxins, it's a common misstatement. Keeping the skin moist, what was another? Transporting oxygen. Water is not that good at transporting oxygen. That's why we have red blood cells. And so I don't, so like here, stuff that I have on the weak answer that's italicized, that's our stuff where I think, oh boy, there's a problem. Under here, the things that are underlined in the better answer, those are things that I'm looking for and are good statements, specific details that are really important. And so you can see, really I don't think there's any construction errors or spelling errors in the second one. One or two errors, that's not a big deal, but when you have a series of errors in it, then then okay, I've got to do something about that. So, the bottom answer I'd probably give a 10 to. The top answer, that's maybe going to get a 6 out of 10 points. Okay. So, and if you have a question about your essay, the answer on your essay, you can ask me, and I'll give you more details. The bottom answer is longer, doesn't necessarily have to be that long to get 10 points. Okay.
I got a question for you, Alan.
Yeah.
Can you hear me okay? Because I have to talk out these AirPods right now.
Yeah, hold on. Let me turn up my sound. Okay, go ahead.
What about now? Can you hear me?
Yep.
Okay. So when you grade these tests, I forget if I did on the last one, but do you show us, like you were just talking to her about what you said about essays and the questions we got right and wrong? If we go back to it, will it show all that stuff or no?
It should now. I have to. People don't take the exam the right time. Some people don't. So I wind up having to reopen the exam for individual people, and I usually that comes with a penalty.
Yeah.
And so, but then I can't show you your answers right away. And
Gotcha.
so that's why it takes me a week to get this stuff done, because I'm tracking down people and waiting for responses and waiting for them to finish stuff. And so, it's what it is. And
Yeah.
we just got to roll with it. And it's harder, if I would get these in class and they're writing, and I would write on them and I'd underline or cross things out. I can't do that.
Yeah.
On the Moodle stuff, or can't do it as easily. So I try and make one or two general comments to essay questions. And I want people to kind of, okay, what I'm looking for is details, and the details should parallel the things that we've talked about in the textbook or in the little lectures that I give you online or in the forums. A lot of times the forums have very good information. And often I'm trying to make the forum make you kind of look at something more specifically. And so, sometimes it'll be something like skin cancer. And so, because that kind of gets to that function of pigmentation and prevention of cancer, and it's a big topic. And so, and it's one we should all be familiar with. And what was I going to say about skin cancer? Well, something, but I forget. Okay. Do you have any other questions?
Yeah, though, you know what? Those questions, as simple as they were, like, why is water good for your body? They actually were kind of hard to answer, like you were talking about.
Oh, yeah, that's hard.
There's a lot in the skin one, too. I mean, yeah, why do we have skin? Well, yeah, I don't know. It's one of those easy, hard questions, I don't know.
Yeah. And that's part of it is kind of learning, like, okay, in this instance, when I ask you, why do you have skin? You could say, well, so your guts don't fall out,
Yeah.
and I want kind of get to the general function of skin. What does skin do? Well, skin is a barrier to the movement of water, so it helps maintain our water balance. Skin protects us from ultraviolet light. And so you have to. It should make you think a little bit about what does skin do, and how can I say this in a way. What did I learn in this section on skin that I maybe didn't know before?
Right.
So, okay. All right. So the exam should be available to you to look at your answers. I think it'll tell you what you got wrong. You can look at the scores for the essay. Hopefully that will help you. Let me stop this sharing, and I want to go back to the chapter on the endocrine system. Okay, so do you see the slide endocrine system?
Yeah.
Okay, all right. So we've talked about the nervous system, which has all these functions, and your memory, your language, things like that. And then it also does a lot of homeostasis, that like the control of temperature is carried out by a brain function or a brain region. The endocrine system doesn't really do any that's not like language or memory, but it is a control center that does a lot of homeostasis. And here, the signals that are involved in controlling other organs are hormones. And the hormones are transmitted in the blood. So for a hormone to work, it has to reach a body cell that has a receptor for it. And so this is how the glands are communicating with organs all over our body. And this is going to have long-lasting effects on cells. So let's see now if I can go to the next slide. So the endocrine system is glands that are scattered all over the body. They have they have lots of effects on homeostasis, and then things like blood glucose, water balance, electrolytes. These are like salts, like sodium and calcium. But it also is controlling growth and development in our immune system and our reproductive systems, things like that. So there's tons of this, and in general, these are homeostatic systems. And so this is, whoops, let me go there. We're trying to maintain a stable internal environment, and so this is going to help us. It's one of these control systems, and so this time it's the gland that's doing it, and not brain. So there's a little bit on hormones. Some hormones are going to act by receptors that are actually inside cells, and they'll change the DNA so that new proteins are made. This would be like estrogen or testosterone do this. Or some hormones are never get inside the cell; they just act at the surface of the cell. These are hormones like growth hormone, insulin works like this. And so they act at a receptor that's embedded in the cell membrane, and somehow they trigger a second change inside the cell, which we call a second messenger. Okay, so all of these things are working to activate through receptors. They're going to activate cells to do different things. There's tons of these glands. I'd like to just focus on the pituitary gland and the pancreas. Okay, and so the pituitary gland is the gland in charge of most other glands, and it does a lot of big functions. So you have all these hormones: oxytocin, antidiuretic hormone, thyroid stimulating hormone, and they're controlling really large things. And so often the pituitary gland will control other glands like the thyroid gland, the adrenal gland, the testes or the ovaries, something like that. And so this is how things like metabolism are controlled, growth and development, sexual maturation, things like that. So really, really important structures. Let's see if I can get down to the pancreas. Okay, the pancreas is one of these other glands that's in the body, and it's important because it's got this really strong link to the digestive system and the most common nutrient that's in blood. The pancreas is actually right next to the small intestine, which is where we absorb most of our nutrients. And it actually makes some digestive enzymes, but it also makes the hormones that control levels of sugar in the blood. And these sugars are the most important nutrients. And right after a meal, our level of sugar in our blood rises tremendously because we're absorbing it. And the pancreas gives our body cells the signal to use sugar as a source of energy, or to take sugar out of the blood and store it when there's excess. And that's insulin is that signal that our body cells need. If we're between meals and we haven't had anything to eat for several hours, another pancreas hormone tells cells to use fat as a source of energy, and it tells the liver to release stored levels of glucose, and that's glucagon. And so this is really important. Glucose is the most abundant source of energy for our cells. It's the most common energy source in blood, and so it's very abundant that way. It's the preferred energy source for all of our cells. They would much rather use glucose. And some cells, like your brain cells, that's all they can use. They can't use fats. They've got to have that. So if something goes wrong with this system, you're in trouble. Okay, and unfortunately, we all know the name of the disease where something goes wrong with this system. That's diabetes. In diabetes, the signal for using sugar is either not produced or it's no longer recognized. So in some cases, in type 1 diabetes, the pancreas no longer makes insulin. Or in type 2 diabetes, the pancreas makes insulin, but the cells don't respond to the message. Type 1 diabetes is usually caused by autoimmunity. So people make an immune response that attacks the pancreas cells. And this may follow an infection. It's more common in women than in men. And once it happens, they will, within a few months, they'll stop ever making insulin because they'll lose the cells that make insulin. And so they'll have to take insulin for the rest of their lives. And so a severe problem. But the more common type of diabetes is type 2 diabetes, where the body cells no longer respond to insulin. Okay, and this comes on gradually, but it can be just as big a problem. Okay, the symptoms for the two types of diabetes are about the same. People are tired. They urinate frequently. They start losing weight suddenly because of this frequent urination. They're losing glucose in their blood or glucose in their urine, and then they can't use glucose as a source of energy, so they start using fat. Because their cells are constantly starved, they're hungry, it fouls up their body fluids because there's glucose at very high levels, so their immune system doesn't respond to injuries well, so they heal poorly. Their nerve cells don't work well, so they have numbness in their hands and feet. They may injure themselves because they don't always feel where their feet are, and so they have a lot of problems, and it's the leading cause of amputation, the leading cause of blindness. The average person that has diabetes loses over 10 years of life expectancy. It's really serious, and of course causes huge amounts of money. And it's not an uncommon problem. Somewhere like 1 out of every 12 Americans has diabetes. So it's really, really serious. And I should mention that type 2 diabetes tends to come on with age and obesity and diets that are rich in processed foods, fats, and simple sugars. And we think what happens is that there's an imbalance. The receptor cells that normally respond to these hormones become insensitive. So a very, very severe problem. Okay, does anybody have any questions? Okay, this is a long chapter. It's a hard chapter. There's all sorts of details. Focus on the pancreas and then the pituitary gland. At least know the names of the other glands, but you don't have to know every hormone of the adrenal gland or the thyroid gland or the other glands. We'll let that pass by. Okay, so let me stop the share here. Anybody else have any questions?
Nope.
Nope. Are you okay? All right. There is a forum on diabetes. There's a little thing to do with diabetes there. I will have another little short explanation of diabetes with that slide. I haven't gotten that ready, but it should be ready soon. Okay, I think I'm going to stop there. We're a little bit short on time. If you have any more questions. Nope. Okay. All right. Hope to see you again next week when things go. We're between exams. We don't have an exam for a couple of weeks here. The week of October 12th. So we've got 2 more weeks really before we have our third exam. We have another kind of big organ system that we're going to go over. That'll be our last bit of organ systems, and then we'll go into DNA and inheritance and DNA technology. So we're halfway through the human body stuff. So, all right. I'm going to end the meeting then. See you next week. Bye-bye.
Yep, see you later.